You individually.
Wait, when did we learn about drop?
Yesterday.
Yes. That shows you how much we learned. So can I write like some of these?
I'm not quite sure what happened to my notebook.
Especially because I need no paper. Does this have to be like full sentences?
When you start.
I have to look up like times.
And you will turn this into me, so don't skimp yourself.
I'm already on my notebook. Oh, yeah. Yeah, I don't have any paper with me, so I'm pulling out that hat.
Yeah, pull it on paper.
Can it be a half sheet?
Sure.
Can we have to be?
I can understand it. For what?
Are we allowed to look at this one? Yeah, do we look at these later? Like,
You can if you want.
one of the 7 types, because like, I don't really love that, man.
That's fine.
I know for.
Didn't I put the 7 types in your notes? No.
Does it have to be something that you learned from class?
No. Just like pulls it out with my.
Kramer, what are the words that go into the food for in the microwave?
What?
Light waves or light waves?
What's your question?
What are the words that go into food in microwaves? I know how there's light waves.
Yeah, it's electromagnetic waves. Which is like
But which one?
all over life.
Oh.
We just only call the ones we see visible light.
Like that.
Done?
Sure. I just did it at home, but that's fine.
And so, because if I say it's not fine, you probably won't rewrite it. But
I'll fold it, I'll tear it off.
it's okay. You don't have to tear it.
I remember reading that drug, not drug, it's a new type of thing, treatment for cancer.
The vaccine.
Pretty effective.
That's a lot.
Yeah, so yeah. It's
A vaccine?
Yeah.
It's like yeah, it like jumpstarts your T cells or something. I can't exactly remember what it is. But like, there's a part where once you get the cancer, the tumor becomes too big for your cells to fight it, so then they just kind of stop. And then so this thing like jumpstarts your T cells, and so they'll start getting rid of this one piece, or like getting rid of that cancer. And then once it gets rid of that, it'll move on throughout your body trying to find more cancer cells, and it'll start getting rid of them. And it said that in a study they did it on rats, and it was effective in 87 out of the 90 rats that they tried it on. You know,
Getting rid of.
getting rid of cancer, like eliminating the cancer in the,
Without harm.
without harm. Because it's a, like the T cells are already, like they're already a natural part of your body, so it's just restarting your body's process of getting rid of it.
One more minute.
No questions. So it says that all life.
You're what? Which one? Because you're.
Like, is it just like
Because you
all
know my word.
The frequency and the wavelength determine whether the radiation is hurt you. I don't know all the ins and outs of that, but based on your frequency and your wavelength, it does something to your cells at a certain point. All right, you ready?
Yeah.
Hey, guess who's on the phone? Summarize what you've learned. Okay, what are electromagnetic waves, Avery Bush?
A wave that consists of oscillating electric
Absolutely.
Require no medium.
They don't require a medium. What do they depend on?
Frequency and
Frequency
wave. That's
and-
what that one.
It was actually such an easy
I thought it was
question, but I
a trick
didn't
question, like they don't
understand
depend on any medium. So that's
Gotcha. What are the 7 types? One person, raise your hand, give me one.
Microwave.
Microwaves,
radio waves.
radio waves,
Infrared.
infrared, IR,
Infrared.
favorite,
X-rays.
X-rays. You guys even said the most obvious one.
Visible light.
Visible light. Okay,
I
two
don't know
more.
for the
Gamma.
Gamma, last one.
You say ultraviolet. No, nobody
Wait,
said
no one said
ultraviolet.
ultraviolet.
What does the sun emit?
Ultraviolet.
lights and everything. I think
Because that's what I-
It probably, I don't know exactly, I know it emits UV, it emits ultraviolet, it emits visible.
That's what I was gonna ask you. You can have multiple.
I think it actually might emit all of them.
Because I was gonna say I knew it emitted UV.
Maybe not, maybe not, maybe not. No, the wavelength and the frequency determines whether we can see it, our eyes can see it.
Yeah.
Like if I shot X-rays right through your eyes, it would,
Yeah.
fresh.
I know
I'm saying that.
It's the atmosphere that blocks out a lot of the bad stuff. Okay, raise your hand if you are willing to tell me something that you found particularly interesting. Emma?
That microwaves literally have microwaves in them. Like,
So you thought you
It
just
like-
had the name?
well, yeah, I never thought about that before. Like,
They're basically shooting radiation into your food, which is, that's why a lot of people think that microwaves are not. Okay, what about you, Steven?
It's actually what I wrote down when I just thought of it.
Okay.
When Isaac was talking about how food flags that they don't.
That's cool, right? Yeah. Yep. Cole?
Speed of light is a constant.
It's crazy, right?
I thought sunlight might be slower than other light.
Yeah.
Why would sunlight be slow?
No, sunlight.
Oh, I thought you said
Okay,
sunlight.
number 3. What is something that you learned that you never knew before? Raise your hand if you're willing to state something that you're like, I didn't know that. But
I don't know if I'll say this right,
yeah.
but when you said that, like in a microwave, it hits the water molecules and then
Basically what you're doing is transferring the energy in your wave to your water molecules, which is going to speed up your water molecules or cause them to vibrate more. And due to contact with the other things in your food, that's how energy gets passed to your entire food. I've never microwaved bread.
Like a sandwich?
What?
Never put like a sandwich in the microwave?
Not with the bugs,
Every
that's
time.
like soggy.
Yeah,
and
you get like,
my
you
favorite
put like a
stuff
piece of pizza in the microwave.
Well, it makes sense why it would get soggy.
Yeah.
Yeah.
Oh.
Oh my goodness.
Okay.
Okay.
Oh. It all makes sense now.
Flat mirrors.
Oh, this is what I've been reading my whole life, ever since physical science for.
Why?
Because you
Because
know the mirrors are fake.
the reflection.
Not mirrors are fake, but our minds are
We
fake.
don't want this, dude.
Yeah, I love. What?
Mirrors are real, how are eyes?
No, I was just kidding.
Yeah, I knew. Are you
Come
serious?
on.
He says that to get us to actually do it.
What do you say?
This is what I'm interested in.
Oh, yeah, but I wrote it so nicely.
You're probably gonna do that.
That might be the most.
Oh my goodness.
Stop!
Sorry.
Bruce and Brian. All right, here we go.
Might be the most.
Okay, here we go. Cheyenne, turn around. Okay, reflection. You guys are all familiar with the vocab word or the word reflection. Okay, we're gonna get more in depth into how this works and why mirrors are the way that they are. We're gonna get to eventually next chapter into lenses and how you can create a real image and the difference between a real image and a virtual image. Okay. There are ways to get an image to actually appear and it be real. That's what this is doing. This is a real image. Okay? You cannot get a virtual image to appear on an object. We'll talk about as we progress here. Okay? It's a change in direction of electromagnetic wave at the surface that causes it to move away. And there really is reflection on all surfaces. Okay? Now, some surfaces absorb more light wavelengths than others, and we'll get into the color schemes and how that works with pigments and stuff. Okay? Now, the texture of the surface is going to determine how it's going to reflect. Okay? Smooth surfaces are going to reflect more predictably. Rough surfaces, you can imagine, won't be so predictable. So if you have your books open, very first page on section 2, you should see kind of an example of what diffuse and specular reflection looks like.
Wow.
Okay? So when you have your rough, just your rough, untextured, or probably more textured surface, you're going to get the reflection to kind of come off not nice and parallel to each other. Okay? Versus when you got it smooth, and you don't have a hand in the box.
Stop, I wasn't even thinking about it.
When you have a smooth surface, the lightweight rays, when they come in parallel, are going to reflect parallel.
Seen Star Wars? Like wall and keep on up.
Yeah.
I have no idea.
There's a scene in Star Wars.
Yeah, so
Sorry, like in mirrors, like block it. So always like one looks a little bit of and it's setting.
Okay, let's look at the next page in your book here. Okay, here's an example of reflection where you can kind of see the light scattering. There's a really important thing, vocab word that we're going to use in our map. Angle of incidence and angle of reflection. Let's say I've got a smooth surface and this is, what's that line called?
The x-axis, y-axis.
Axis of symmetry.
That's what you want. Which one do you want?
In physics, what is the line perpendicular to the surface
Normal
called?
force.
Normal.
Okay, I almost said.
No, this is not the normal force.
Well,
I would say
That's just the normal line.
Okay.
Just a normal line.
Okay. The reason why we call it a normal force is because it's a force. This is not a force. That's just a line perpendicular to the surface.
Okay.
It's a perpendicular line.
So it's
It's just
A normal line.
If I had called it.
it's a generic line. I can't wait to get the irregular
I tried to
lines.
make a funny joke.
My body is normal to the surface. So Well, it's a normal Kramer.
Is it though?
Could I also call it a normal gravity?
Okay. So, when light comes in, close enough. Okay. This is called the incidence ray. Okay, and as you can imagine, the outcoming would be a reflection. Okay, the angle between your incident ray and your normal line is called your
Normal
incidence.
angle.
That's kind of it, the force due to gravity.
Or the angles
Uh-huh. Okay? And the angle from your reflected ray and your normal is the angle of reflection.
Oof, reflection.
And guess what's true about those two angles?
They're equal.
The angle of incidence will always be the angle of reflection. Okay, we're just kind of setting the stage here because so with some vocab words so we can get into doing mirrors and doing the math behind mirrors because we can predict exactly where a image is going to form. What's the math?
Mirror and see where the image is from.
What did you say?
I said, or we could go look in a mirror and see where the image is from.
Kramer,
Can you measure behind the mirror?
GPS kids, so we can fetch reflection.
Oh, I don't know what that is. Okay. What is true then about electromagnetic ray, or maybe I should just specifically say light? Light always moves in a what?
Straight line.
Straight line.
Well,
Yeah.
but light can bend around objects.
Yes, but it moves in a straight line. It actually,
It's a bit.
this is going to be crazy for you to understand. It goes like this.
Go ahead, understand
It moves in a straight line like that. Because it moves so fast, it doesn't like curve.
That's what I mean. That's what I mean. I mean like if you shine a light at a ball, like a mirror ball, it will actually like make a light in a shape instead of a shadow.
Thank you.
Yeah, that's just because it bends. Light can bend.
It's always getting lighter.
But it still moves straight. Yeah, like if it's going like this, it can bend like that, but it's still straight.
Remember when Kramer said he was the greatest guy with light? I've only got
It's part that got more
Well, I've
problem.
highlighted it was.
So yes, so sorry, when you said, I thought when you said, I thought you meant like in curvature. Like you said that.
Why is it big?
I don't believe so. Because even when you're talking about like fiber optics, what that is it's still moving in a straight line, but it's just like continually reflecting. And slowly it progresses through, even though it's not slowly because we know the speed of light is extremely fast. So even though it's bouncing back and forth a bunch, it's still going to go through there real fast.
My hair was probably already done.
I'm going to not go over this. Alright, last thing. Flat mirrors. No matter what, you can never get a flat mirror to produce a real image. It will always be a virtual image. We'll talk much more about what a real image is and a virtual image is as we progress. Okay, we're just kind of setting the stage here. Okay. They will always produce a virtual image that are the same distance from the mirror surface as the object is. So when you stand in front of a mirror, the distance from you to the mirror is how far the image behind the mirror is.
Wow.
That's scary.
My mind.
Okay, so like if that's a mirror and I stand here, the distance from me to the mirror will be how far your image is behind the mirror.
Whoa. That's weird.
Okay?
We see that every day.
So, and I'll show you what I mean because it's kind of crazy. It's crazy. It is.
How do you figure that?
I think this is cool.
How should mirrors be real for eyes on?
How are just normal frames?
It's not super. Okay, now listen. The image formed by rays that appear to come from the image behind the mirror but never really do are called virtual images. Okay? A virtual image can never be displayed on a physical surface. So I know you're probably thinking, well, what is a real image? Well, actually what happens, a real image is one where light actually converges at a point that creates an actual image. Like that's what this is doing. Light is being shined through a lens and it's converging at a point right on here that I can actually show it. Okay? I couldn't take a virtual image and put it on a physical board. It's not possible. It wouldn't show up.
So, like, you see yourself in the mirror, but if you move the mirror, your image is gone, that's what you're saying.
I'm not sure if that's.
Give an example of virtual image.
The only problem is I had it in there. I had it in there.
Say that again.
I don't remember what you said, so it's
I don't know.
not.
What's an example of like
He said
a
the lights
virtual
coming down
image
and-
not being able to be?
You just said it.
Well, you can. So
I know, but
I can't give you an example of something you can't do.
Like, I don't understand what virtual image is. Like, what would be?
Do you remember what you
A
said?
virtual image is one where light is actually not coming from that image.
Wait, so how do I know I'm not? I'm not looking at virtual camera right
Okay, so here's what I mean. So it'll make more sense when we get the lenses, but light's coming off here and it's converging at one point right here and then it's reflecting off that to your eyes. Okay? An image behind the mirror, light is not coming from behind the mirror. There's no way. Right?
now? Oh, yeah.
It's a virtual image. So if it never ever converges at that point, you couldn't actually get it to reflect and come back to your eyes and see it. Okay?
But you do see it.
So when we're looking
But
at
it's because your
this,
brain makes an image.
What about
Yeah. That light is not coming from the object behind the mirror.
Oh, so like you're a whole flashlight in the mirror.
there is no object.
Like when I step right here and put a mirror, the image of me behind the mirror is light's not reflecting from the image behind the mirror to me. It's hitting the mirror and coming into my eyes, and my brain says, I'm seeing light of me. Where did it come from?
There you go.
I will show you.
What is live? What are
I can't tell if I supremely understand this or if
I know.
It's complicated.
I'm pretty sure
Okay?
she's
So here's what happens.
complicated.
Light hits this pencil, it reflects, hits the mirror, comes back and your eye sees that light. Well, it's light from here, right? It reflected out this. Well, your brain cannot comprehend that light can reflect.
So it just reverses it, like it flips it, or no?
No, your brain says it took this much time to get from here to here, and your brain's like, I only know light as in a straight line. So your brain creates an image thinking that the light actually came from here, and it makes that image. There's nothing there. There is nothing there.
It just basically.
So how is it like?
It creates another image. Your brain sees light.
Wait, how do we know our brain's not creating the wrong image?
Well, there's a demon in the mirror.
Magic mirror on the wall, show me the pencil.
I mean, if you have an object in front, you can theoretically understand that light coming off of that, hitting the mirror, coming back and hitting your eyes.
Well, if we can't, our brain can't. I don't understand how we have light. Like,
It's just
like light in the mirror doesn't matter.
We're not. Light is hitting this object. Light hits the pencil, hits the mirror, then hits our eye.
I just
But why?
Actually, I want to be able to see ourselves in
And
the
then the light
mirror.
would now.
Oh yeah, light hits us, reflects off of us, hits the mirror, and comes back and hits our eyes, so we see us.
You do not.